In this video I'm going to be looking at the solution to question 4 of the June 2011 Edexcel M1 paper. The topic of the question is kinematics. So we're told in the question that a girl is running a 400-meter race and she does this in a time of 84 seconds. To model the race, we assume that she's starting from rest. She moves with constant acceleration for 4 seconds, reaching a speed of 5 meters per second. She maintains this speed for 60 seconds and then moves with constant deceleration for 20 seconds. She crosses the finishing line then with a speed of v meters per second. So in part A of the question we're asked to sketch that information into a speed time graph. And then in part B, find the distance run by the girl in the first 64 seconds of the race. Part C, to find the value of v, which is her final speed. And in part D of the question, to calculate the deceleration of the girl in the last 20 seconds of her race. So in part A then, we're sketching a speed time graph. So first of all, putting the axes on, and then the first part of the motion we've got a constant acceleration, so a line moving up with a constant gradient, then remains at a constant speed until finally decelerating to some speed that we have to find in the final part of the question. In one of the parts of the question. So putting the numbers onto there, we have the velocity on the axis, meters per second. We're told that this velocity is 5 and occurs after 4 seconds. She maintains that for 60 seconds, so this point is now 64 seconds. And final time 84 with a velocity of v. So there's our speed time graph, and there were 2 marks given for that, just 2 B marks, so no method required, simply for getting the shape and the labels onto there. In the second part of the question then, the distance run by the girl in the first 64 seconds. So this is using the idea that the distance is going to be the area under the graph, and the shape of this is a trapezium. So in the first 54 seconds we have the area of the trapezium as a half of the parallel sides, so they are 60 and 64. Multiplied by the distance between them, which is 5. And that turns out to be 310 meters. We have to calculate the value of v. Well, if she's run 310 meters in the first 64 seconds, she must run the difference of that, so that's 90 meters. It's a 400-meter race, so runs 90 meters in the last 20 seconds. So again, we've got a trapezium there for that final part, the area of which is 1/2 of, this time we're looking at the verticals as being the parallel sides, so 5 plus v, and then the distance between them is the time difference, 20, and that must be a total of 90. Well, we can see therefore that dividing through the 2 there to give us 10, and then dividing both sides by 10 means that 5 plus v must be equal to 9, and v is therefore 4 meters per second. The deceleration is simply the change in her speed divided by the time that took. Well, the change in the speed goes from 5 down to 4, and it took 20 seconds. So that's 1/20 or 0.05, and that will be meters per second squared. The marking in this part of the question, a method and accuracy mark for using the correct equation there, and a mark for getting the final answer of 310. The second part of the question a little bit longer, but again method and a mark for the left hand side, and the fact that that must be equal to 90, second a mark. If that was done correctly, then there's a what's called a dependent method mark. So depending on what you've done so far, you pick up another method mark for getting 5 plus v equal to 9, and then a final a mark for the answer 4 meters per second. The final part of the question, just 2 marks, a method mark and an accuracy mark for the answer being equal to 1/20 or 0.05. That's the end of that question. You can find solutions to other questions at www.furthermaths.org.uk.